All right, guys, let's get this review video done for test 24. It says, find the first 5 terms of the recursively defined sequence given that A1 is 3. Now, recursive means that you have to have the previous term to get the next one. So A1 is 3. Now, when you read that, that means 8. That means the next term is 8 times the previous term minus 2. So to find A2, I'm going to do 8 times the previous term, which is 3, minus 2, and get 22. To find the third term, same deal. 8 times the previous term minus 2, 160, 176, I think that's 174. The fourth term, 8 times the previous term minus 2, which is 1390. And the fifth term, last one, 8 times the previous term minus 2, which is going to be 11,118. All right. Number 2, find the nth term of a sequence whose terms are given. Now, this is one I can't give you great strategies for. You got to figure out the pattern. Now, the pattern on the top, they're increasing by 1 every time. So anytime it's arithmetic, use the arithmetic stuff you know. Remember, D goes in front of the N. So the difference here on the numerator is 1. So I'm going to put 1 in front of the N. And I got to get the first term. Well, the first term is 3. So 1 plus 2 is 3. Got to check that with some more. 2 plus 2, 3 plus 2. Yep, that works just fine. On the bottom, I'm looking at like 2, 4, 8, 16. Those are actually the exponential forms of 2 to the n, like 2 to the first, 2 squared, 2 cubed. So there it is. And again, not really strategy as much as you got to play with that and just figure out what's working. All right, number 3, find the first 4 partial sums and the nth partial sum. Okay, so we got to find the first 4 terms first. So the first term, plug in 1, like this, you're going to get 1. If you plug in 2, 2 times 2 is 4, minus 1 is 3. If I plug in 3, 2 times 3 is 6, minus 1 is 5, and 4. 2 times 4 is 8, minus 1 is 9. So the first 4 partial sums will be this. The sum of the first one is 1. Sum of the first 2 is 4. Sum of the first 3 is 9. And sum of the first 4 terms is 16. All I did is add those up as I went. Those are the sums. So that's really the answer right there. Then it says find the nth partial sum. So I'm looking for a pattern. It goes 1, 4, 9, 16. Guys, those are just squares. 1 squared, 2 squared, 3 squared. So let's put n squared. And that's the pattern of the sums, which is what it wants for the nth partial sum. Number 4, write that without using sigma notation. And all you have to do here is write the numbers out. You don't have to actually add them up. So I'm going to start off by plugging 6 in there. So it'd be 6 times 9, which is 54. Plug 7 in, which would be 7 times 10, 70. Plug in 8, 8 times 11. Plug in 9, 9 times 12. And there you go. Number 5, rewrite using sigma notation. Okay, so I'm going to draw my sigma. I'm going to try to go n equals 1 first. There's only 4 terms, so I'm going to try 4 on the top and figure out what's going on here. It goes 8 plus 4 plus 8 thirds plus 2. I'm trying to figure out what's going on there, and it just hit me. That's the 8 over 3 is kind of the giveaway. It's really 8 over 1, 8 over 2, 8 over 3, and 8 over 4. That's what the pattern is. So my sigma is going to have an 8 over everything. And then my numerator, the denominator, is just like 1, 2, 3, 4. So I just put an n down there. And if I plug in 1, then 2, then 3, then 4, I get the same thing. So there's that one. Number 6, evaluate the series. From 5 to 11, if I put in 5, I'm getting 25, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared. I've got to add those up. Obviously, I think you know where the calculator button is on this one too, just saying. I'm getting 476 on that one. We'll see what happens. Number 7, find the first 4 terms and the 100 term of that sequence right there. So the first 4, again, just plug in 1. If I plug in 1, 1 squared plus 1 is 2. A2, the second term, plug in 2. 2 squared is 4 plus 1 is 5. The third term, 3 squared is 9 plus 1 is 10. The fourth term, 4 squared is 16 plus 1 is 17. And find the 100th term, 100 squared is 10,000 plus 1, 10,001. Number 8, find the nth term of the arithmetic sequence where A, which means the first term, is -8 and D is 6. What's the 10th term? Okay, so here we go. The nth term, remember D goes in front of your N every time. And it says the first term is -8. What do you do to 6 to get the -8? You subtract 14. So there's the nth term. There's the first answer. So to find the 10th term, I'm going to say 6 times 10 minus 14, and that's going to be 60 minus 14, which is 46. There's the 10th term. Now, if that first part, if you want to do it this way, you can also do the whole formula and go like the first term plus n minus 1 times d, like that, and then just work it out. Distribute that 6, and you can see the negative 8 and the negative 6 is going to give you the minus 14 that was in there. So either way is fine. Number 9, is it arithmetic? You got to punch it in your calculator to see if the difference is the same, and this time, no, it's not. So that's a no verse. It's not the same. Number 10, find the common difference of fifth term and the nth term. Okay, the d is 4, it's increasing by 4. The fifth term, that's right, we got to do this part first. Right? Well, the fifth term is going to be the next one, right? So the fifth term is going to be 17. The 100 term, let's do this. Let's find the nth term first. The nth term, remember how we do this. You put the d in front of your n, so 4n, and the first term is a 1. How do you get from 4 to 1? You subtract 3. So there's the nth term. So there's an answer, there's an answer, there's an answer. And then the 100th term, just going to plug 100 in for n. 400 minus 3 is 397. There's the 100th term. Number 11, find the 8th partial sum of that sequence, where arithmetic sequence. And because it's arithmetic, we can use our formula, which is this right here. So how many terms, what I don't know on this one is how many terms there are. Okay, so when I set this up, I'm not sure what my n is. I do know the first term is 100. There's 8 of them. Sorry about that. There's 8 of them. I do know how many. There's 8. What I don't know is what the 8th term is. So to find the 8th term, I'm going to do the other formula. So the formula is, remember the d goes in front of your n, and the first term is 100. How do you get from negative 5 to 100? Well, you add 105. So to find the 8th term, I'm going to plug in an 8 for my n, which gives me negative 40 plus 105, which is 65. So that's what I'm going to punch in my calculator to see what I get here. And when I punch that in, it looks like I'm getting 660. One double check that real quick. 8 sum, 8 over 2. First term's 100. Had to find the 5th term. Had to find the 8th term. Looks good. Number 12, also find the sum. First of all, check it out. Is it arithmetic? It's definitely increasing by 1.5. It is arithmetic. So I'm going to set that same formula up. This one more time. This time, what I don't know, which I didn't think I knew the first time, is I don't know what it is. I don't know how many terms there are to get to 30. So I'm going to leave that blank for a second. The first term is negative 3. The last term is 30 for sure. Got to figure out what the n is. I'm going to go back to our other formula. So I'm going to go an equals, remember d goes in front of your n. It's increasing by 1.5 each time. So it's 3 halves. It's increased by 3 halves. How do you get from 3 halves to negative 3? Well, negative 3 is really negative 6 halves. So to get the 3 halves from there, you would actually subtract 9 halves. So there's my formula. I need to figure out what n is. Here's what I'm going to do. The 30 is the last term. So I'm going to say 30 is 3 halves n minus 9 halves. So I'm going to move that 9 halves over. I'm out of room here. I'm going to move the 9 halves over. 30 is really 60 halves. So it's going to be 69 halves. So if I divide 3 halves into 69 halves, I'm getting 23. That means there's 23 terms there. So my calculator, I'm actually going to punch in 23 halves times 27, which is what the inside of my parentheses is, and see what I get. It looks like I'm getting 310.5. Or you could obviously put that as like, I think, what's that, 621 over 2. You can run as a fraction also if you want to. Okay, we've got a couple of review ones here. Log stuff from before break. Anytime you see 2 logs subtracted, you can't subtract them. That always means division. So I'm going to take those 2 logs, write them as 1 log using division. And anytime I see 1 log, you do the old finger thing, the pattern. You're going to do 5 to that power equals that. 5 squared equals that. So I have x plus 1 over x minus 1 equals 5 squared. And 5 squared is 25. Now I'm just going to cross multiply. Going this way, it's really over 1. So I get x plus 1 equals 25x minus 25. Move the x over here, move the 25 over there, divide by 24, I get 26/24, which is really 13/12. Make sure to check your answer, make sure it keeps the logs positive. It does. Good. 3 more. 14. List all the possible zeros, then find them. Remember, when you make your list, you put plus or minus the factors of the last number, which is 3, over factors of the first number, which is 2. So I'm going 1 over 1, 3 over 1, 1 over 2, 3 over 2. I'm going to punch that equation in my calculator and see which one of those works real quick. Okay, I punched in my calculator and saw that 3 worked, and I accidentally went ahead and did the synthetic without turning the video back on. So 3 does work, got a 0. I'm going to take the numbers on the bottom now, the 2x squared plus x minus 1. See if I can solve that. So I'm going to go slide, divide, slide here. Slide that 2. Factor what you got. Divide by the 2, which gives me x plus 1. I like the x minus 1 half just fine. So my zeros are these. My zeros are 3 from the beginning, negative 1, and also 1 half. There's the 3 zeros. Number 15, simplify. Which means multiply by the conjugate. The conjugate of 2 plus 4i is 2 minus 4i. The bottom is going to do foo, which is going to be 4 minus 16i squared on my denominator. My numerator, I'm doing FOIL, so I'm doing first, outer, inner, and last. And now it's just a matter of simplifying everything. My numerator is that 20i squared really becomes negative 20. 6 minus 20 is negative 14. I got a negative 22i. On the bottom, I've got that I squared makes it really a positive 16, which is 20. And so because they're all even, I'm going to take a 2 out of everything. 2 out of 14, 2 out of the 22, and a 2 out of the 20. And there it is. And the last one, got to solve this one using logs. So I'm going to put the exponents in the front. Let's do log, make it a little easier. X log 6. And the reason I'm using log is because it was a 10. Log 10, remember that means log 10, 10. The base is really 10. Log 10, 10 is 1. That's really gone. So 1 minus x equals x. That should be a 6 right there. Log 6. I need to get my x's together, so I'm going to leave the 1 over here and go x log 6 plus x. I'm bringing that x over. Let's factor out the x here, which leaves log 6 plus 1. So x is going to equal this. X is going to equal 1 over log 6 plus 1. I'm going to try to punch this in I didn't bring my graphing calculator home, so I'm going to try to punch this in my phone calculator and see if I can make it work. We'll see what happens. Give me 1 sec. Okay, check this out. I got 0.5624. You need to double check me there and make sure that looks good. Like I said, I didn't have my graphing calculator. So pretty good test this time. Make sure you got it took a little while, so make sure you know your stuff tomorrow when you come in. So make sure you get done. But should be great. See you later.